Hey Brandon, this is Mr. Caslin. I knew I wasn't going to bed tonight till I solved these two problems. They were bugging me a little bit, but I think I've got some solutions that you can start looking at. Okay, this first problem was a system of logarithms. Okay, we had a system of equations that had logarithms in it. I think we're on the right path when we noticed that these two were inverses of one another. These two were inverses of one another. Okay, what we're going to do is we're going to do substitutions. Remember, system of equations, we can use substitution or elimination. We're going to use substitutions to solve this problem, or at least that's the way I figured out to do it. Okay, so since these are inverses of one another, let's make these more simple. I always like to make things more simple to see the patterns more clearly. So what we're going to do, and you're going to see these type of substitutions more when you get to calculus, but let's define a variable a, and let's say a is equal to excuse me, log base 9 of x. Okay, and we're going to let b is equal to log base 8 of y, which is this one down here. All right. So if we do that, we can make this equation much more simple. Okay, we have, since we know these are inverses, if this is a, we'll make this 1 over a. Since log base 8 of y is b, that makes log base y of 8 1 over b. So we have a plus 1 over b is equal to 2. 1 over a plus b is equal to 8 over 3. Okay, this still doesn't work very well for an elimination, because when we add these inverses, these are multiplicative inverses, not additive inverses, so we're not going to be able to get those to cancel. So what we're going to do is a substitution. We're going to solve for a. Okay, just subtracting 1 over b from both sides. Remember what you do with a substitution. A is equal to this, so you're going to plug that into the other equation. Okay. All right. When you do that, you get this equation. Notice we can solve this equation now because we have one equation with one variable. All right, I'm going to leave this part up to you now. You're going to have to solve this equation, set it equal to 0, and find the solutions to it. Okay, I will give you a hint that it will end up as a quadratic. Okay, and you're going to end up with two solutions. Okay, so that's not easy. You have to combine fractions. You can cross multiply, do a whole bunch of things to solve for this, but there's a lot of work to get from here to here. Okay, it took me a while to get to here, and then you're going to solve this like a quadratic. Okay, so you're going to end up with two different, because it's a quadratic, you're going to end up with two different b's. Okay, again, it's a quadratic, so you get two different b's. It's substitution, so once you figure out what b is, substitute the b back into, let's see the best way to do this. Well, yes, yeah, you take the b and substitute back into one of these equations, and then you solve for a. Okay, so you're going to get a series of a's and b's. Okay, now be careful. Once you know a and b, you're not done yet. What we really want to know is x and y. So you take your a's and b's, plug them back into here, and then solve for x and y. Okay, so there's going to be two different solutions. I will give you one of them. One of the ones that I solved was you get x is equal to 3 and y is equal to 4. Okay, and see if you can figure out what the other solution is. All right, so I gave you a strategy. There's a lot of work here still I didn't fill in, so see if you can figure out the rest of it. This is a substitution problem, and what we did first is we simplified the problem. Okay, found a and b, plug a and b back into here, figure out what your x and y is. Okay, hope this helps. This is a difficult problem, so even with this strategy, it still takes a while to get the correct answers. All right, talk to you later. Thanks.